Alright, we are once again doing a test review. Welcome back to the channel. Alrighty, let's see. Number 2. I'm going to pick and choose which ones we do here. For this polynomial, we're going to list out the zeros and the multiplicity of each zero. And we can identify them right now as where they touch or cross the x-axis. The first one that I notice is at -3. The next one I see is at -1. And the last one I see is at +2. Okay, and then we're going to look at the multiplicity of these. This one is a linear crossing. So we would say it has a multiplicity of 1 because it just crosses straight through. The one where it bounces off, so it comes in and bounces off the axis, we would say that's a multiplicity of 2. So this 0 would be a multiplicity of 2. And the one where it does a swoop, where it comes in like a upside down parabola and it leaves like a regular parabola, we would call that a swoop, and that's a multiplicity of 3. The way we can write down the factored form of this function, we would write f of x is equal to x plus 3 times x plus 1 times x minus 2. So we're just going to flip the sign of each of the zeros, and that would be my factors. And then we take these multiplicities and apply them to each power. So we have x plus 3 to the power of 1, x plus 1 to the power of 3, and x minus 2 to the power of 2. This is exactly how you would do number 1, so feel free to do that one as well. Looks like there's no bounces on number 1. That's your hint for that. All right, next one. What polynomial must be added to x to the 4 plus 2x minus 3 so that the sum is x to the 3rd minus 4x squared plus 2x minus 5? I'm going to write down the sum that we want. Underneath a big addition. Okay. And we're going to take the original, which is x to the 4 plus 2x minus 3, and we're going to write that up top. Okay, but we need everything to match up. So the minus 3 we're going to put above the minus 5. The plus 2x we're going to put above the 2x. And then the x to the 4 needs to go all the way over here. Because in our original equation, we don't have anything x to the 4. Okay, and the way we think about this is this one has some zeros where x to the 3rd would be and where x squared would be, since we don't have any x to the 3rd or x squared terms. Okay, so to figure out what this polynomial must be, it also helps to write a 0 in front of the x to the 3rd, because we need to somehow get rid of our x to the 4th term in our final sum. Okay, so to figure this out, I think it's easiest to start on the right side. And the question we would start with is, what do I add to -3 to get to -5? And the answer to that would be a -2. Okay, -3 plus -2 would give me -5. What do I add to 2x to get to 2x? This would be a 0, because we need to add nothing to that, because we need for that to not change. And then the next one would be the -4x squared. What do I need to add to 0 to get that? Well, I need to add exactly what I have, -4x squared. Same thing for the x to the 3rd. We have 0 plus x to the 3rd would give me x to the 3rd. And then finally, we need for there to be no x to the 4th term. So we need to realize that this is 1 x to the 4th, and we need to add -1 x to the 4th for these two to cancel out. So if we take this would be my answer. It would be -1 x to the 4th, and we don't need to write the 1, plus 1 x to the 3rd, minus 4x squared, plus 0 minus 2, and we don't need to write the plus 0. All right. On the next one, number 5, it says, if the expression above is rewritten as ax squared plus bx plus c, where a, b, and c are constants, meaning that they're just numbers, what is the value of c? To do this, we just need to simplify everything, and to do that, we need to just distribute this negative 3 to everything inside. So we're going to start by writing down the original, negative 2x squared minus 5x plus 14. Okay, and then to that we're going to multiply negative 3 times x squared to get negative 3x squared. We're going to take negative 3 times negative 4 to get positive 12x. And then we're going to take negative 3 times 4 to get negative 12. We're going to do this and then combine all our like terms. So we have our x squareds. So we have a negative 2 and a negative 3, which we can combine to negative 5 x squared. We have a negative 5x and a positive 12x. So we'll take negative 5 plus 12, which would be positive 7x. And then we'll take the positive 14, plus negative 12, which would give me positive 2. Okay, and the question here, what would the value of C be? Well, here we have A is negative 5, B is positive 7, and C is positive 2. Okay, so it's just about simplifying your answer and getting something that looks like ax squared plus bx plus c. And we did that, and with all the color coding here, hopefully this all makes sense. Alrighty, make sure to read number 4 carefully. It's looking for the value of b in that equation. Alrighty, number 6. For this one, we need to multiply these two things together, so we're going to need a box. Good enough. And we will just need to multiply 5x minus 2y squared times 5x plus 2y squared. Okay, so we're multiplying from the top and from the left for all of these. We're going to take 5x times 5x, that would be 25x squared, which is the first part of my answer, 25x squared. Let's see, we'll take this one now, we'll do negative 2y squared times 5x. That would be negative 10. Negative 10 times x times y squared. Then we'll take 5x times positive 2y squared. This would be 10 times x times y squared. Okay, and what you'll notice is that these diagonals cancel each other out. We have a positive 10xy squared and a negative 10xy squared. So we can think of that as canceling each other out just to be a 0. And then finally, the last box, we'll take negative 2y squared times positive 2y squared to get negative 4y to the power of 4, because we have to take y squared times y squared. Okay, which is the last part of my answer. And if we just get rid of the 0, this will be our final answer for this problem. Try out number 7 on your own. It's just like this one. All right, for this next one, if you're not in my class, if you have a different Algebra 2 teacher, you probably did not learn this way. So feel free to skip this problem and just do it the way your teacher taught you. For my class, you guys can just do this the way we always do it. We're going to take our factor, x minus 4, put that on the side. And we're going to take the first term and put that right here in the top left box, 2x to the third. And everything else that I write will be a part of the actual math. And I'll change my pen color to show you that this was just the setup, much like that's the setup for number 9. In a very similar way. Okay, once we have it here, we just have to go piece by piece like a puzzle. On top of this needs to be 2x squared in order for us to multiply to get 2x to the third. Okay, which means that this has to be negative 8x squared, because we have 2x squared times negative 4. Okay, the next thing that we can figure out is this diagonal. And what we know is that right now we have a negative 8x squared, but we need a negative 7x squared. That means that in this diagonal, okay, aka in this box, whatever this is needs to add up to negative 7x squared. What plus negative 8 is negative 7? Okay? Or in other words, negative 8 plus what is negative 7? That would be a positive 1x squared. Okay, because if you combine those, you get the negative 7 that we want. Once we have that written down, we can figure out that this must be just regular x. Okay, because we have x times x equals x squared. And that'd be a positive x. Then we can take x times negative 4, that's negative 4x. Oops. Okay, and then we realize, okay, so we have negative 4x, but we need negative 7x. That means that in this diagonal, we need to put a negative 3x. Because these will combine to give us the negative 7x that we want. Which means that this has to be a negative 3, because negative 3 times x gives us the negative 3x. And negative 3 times negative 4 would be negative 12. Well, positive 12, excuse me. Negative times a negative would be a positive 12, okay? But we want a positive 13, which means that we need to add 1, and this would be our remainder, a remainder of 1, okay? The answer itself is right here. So this expression is equal to, or when you divide these two things, it is equal to 2x squared plus x minus 3 with a remainder of 1. Okay, this answer still should be correct even if you use a different method. So if you use a method other than this and you have a different Algebra 2 teacher, check your answer anyways. Alrighty, the next one we're going to do is right here, number 10. We're just going to simplify this expression. And the good news is the first two, all we have to do is get rid of the parentheses. So it is literally just rewriting this without any changes. So we have plus a negative, so we're just going to write minus x to the third plus 5x squared minus 1, and that is the first two terms just put together without any parentheses. And then we need to take this negative 1 that's in front of the parentheses and distribute that inside. So this positive 3x is now going to be a negative 3x squared. And this negative 2x is now a positive 2x. Okay, the last thing we have to do is combine all our like terms. So I'm just going to look for the highest power that I see, which is x to the third. And I'm just going to highlight all of those the same color. You can also just underline everything that you use and cross it off when you're done. We have 4x to the third minus 1x to the third for a total of 3x to the third. And like I said, you're welcome to cross stuff off after you use it, so that way you don't accidentally use it again. Then we're going to do the x squared terms. So I see a 5x squared and a negative 3x squared for a total of positive 2x squared when I combine those. And we can cross those off after we use them. Then we have, we have a positive 2x and a positive 2x, and those are the only things with x. So this would be plus 4x after we combine it. And then lastly, we have the negative 11 minus 1, which we can combine to have negative 12. Okay, so it's all just about rearranging it, getting rid of those parentheses, so that way it's just combining like terms like you did in Algebra 1. All right, for the last three problems, we're going to be using Desmos. So for number 11, if you just type in x to the third minus 125, all we need is at least one factor. And if we type it in, we can see that, oh my goodness, we can see that all I did was type it in. And we can see that it crosses at 5, 0, which means that one of my factors must be x minus 5. Okay, so that's just one of the factors. There is another. We could divide this by x minus 5 to figure out what the other part of the equation is, but all we need is one factor for this problem. Number 13 and 14, however, we need all the factors, which is kind of like number 1 and number 2. It's kind of like the same idea. If we just type this in, so I'll put Desmos on all these. And I'll let you do number 13 on your own. For number 14, if we just type this in, we get this graph right here. Oh my goodness, I have a big head. Okay, which crosses at -1 and 2. And if we try to type in those two factors, x plus 1 times x minus 2, we get a graph that doesn't look exactly the same, which means that we need to pay attention to the multiplicities. We have a multiplicity of 1 for this factor, so it needs to be the power of 1. And this one is a quadratic bounce. It bounces off, so this power must be 2. And if we show that equation, we can see that it's the same. So we have x plus 1 to the power of 1 times x minus 2 to the power of 2. This would be equal to x plus 1 to the power of 1 times x minus 2 to the power of 2. Okay, it also says find the zeros. It would be x is equal to -1 and x is equal to +2. Alrighty, hopefully that was helpful. If you're in honors, there's some other stuff that you need to look at with your own teacher on your review. And if I'm not your teacher, like I said, the long division might look way different than what you're used to doing. That being said, have a great day. Hopefully I'll post this today on Tuesday. But yeah, have a good day. Goodbye.